Hello and good morning. I'd like to welcome you on behalf of Pan-Europe and its member organizations to the press conference on the widespread water contamination by unregulated forever breakdown products of PFAS pesticides. My name is Selina Engelmeier. I am press officer at Global 2000 Friends of the Earth Austria, and I will guide you through this morning. Today, we will get inputs from 3 experts. After the inputs, journalists will have the possibility to ask questions. And after that, we offer breakout rooms in French, German, Croatian, Swedish, and Dutch. But you can also stay in the English-speaking main room. We will send out the press release and the report right after the press conference. Before we start, I would like to inform you that we will record the press conference. I hope that that's okay for everyone. What are we talking about today? 5 member states have recently submitted a proposal to the European Chemicals Agency, ECHA, for a ban of the problematic chemical group PFAS, also known as Forever Chemicals. The EU Commission welcomes this ban on PFAS. However, according to the proposal, there should be an exception for PFAS pesticides. In February 22, a joint research by Pan-Europe and its member organizations revealed a sharp increase of the contamination of European fruit and vegetables with PFAS pesticides. Pan-Europe has now investigated what happens to these PFAS pesticides in the environment. Water tests were carried out in European waters and groundwater. The search was for the Forever Chemical TFA, which remains from pesticides. I'm pleased to welcome 3 experts today who will report on the test results and classify them ecologically and politically. Salomé Ronel is policy officer at Pan-Europe. Pauline Savant is toxicologist and project leader at Génération Future. And Helmut Burtscher-Schaden is biochemist at Global 2000 Friends of the Earth Austria. Let's get started. Helmut Burtscher-Schaden, what did you research and what did you find?
Thank you, Selina. Hello, everyone. As Selina already said, I'm a chemist. I worked on environmental chemicals for 20 years, and today I show you what, to my best knowledge, is the largest widespread contamination of surface and of groundwater bodies in Europe in history by a man-made chemical. And in order to better understand and better contextualize the findings, we have to take a look first into the chemistry of PFAS. It's a very brief look. This is a typical PFAS pesticide, and what is interesting for us is this group. It's a carbon atom that has 3 fluor, and this is what makes it a PFAS. In the environment, this pesticide and other PFAS pesticides degrade or break down to a product that is a forever chemical. It's one of the most stable chemicals ever observed. Man-made chemicals, of course, organic chemicals. And when we look into it, it's similar to the most prominent PFAS chemical that we know. It's PFOA. It's the chemical that is meanwhile 70 years old. It has been invented by a US chemical industry company, 3M. And it's, if you want, the big brother of TFA, because it has the same structure, but the length of the chain is different. That's why it was called a C8 by the owner, by 3M and by DuPont, who have made it. The chemical turned out very early to be problematic for health and for the environment, very problematic. When this was obvious and no one could deny it anymore, they changed to smaller chemicals. They called them then C6 because only 6 carbon atoms in the chain, but they also turned out to be dangerous, and they also have C4 chemicals. Also, they are dangerous. What we now see here is a C2 chemical, and actually we should hope that this one is not in the same category of hazards and risks as the others of the family. because what we found, and not only we, but also authorities know about it, at least in some member states, is not really assuring. We found this chemical, which is a breakdown product of about 2,000 different PFAS molecules that are industrially produced, but mainly of pesticides, in every sample that we analyzed. We did 23 European surface waters from 10 member states, and we found concentrations ranging from 370 nanogram per liter to 3,300. The first one, the lowest concentrations were found, interestingly, in Austria, where I come from, so I'm happy about that. The highest in Elbe, in the north of Germany, also Seine, France, was quite contaminated with this chemical. TFA, trifluoroacetic acid, a very stable and persistent chemical. The mean value we found is about 1,200 in surface waters. And we also did look in a few samples of groundwater. It was only 6 samples from 4 countries, but the picture was quite clear, and it's similar to what we know from what was investigated in Germany, for example. Also here, this chemical is widespread, and the mean value, and this is really surprising, is in the same range, 1,000 nanogram per liter, than in surface water bodies. But normally you would expect that groundwater is protected much more because of the natural filter function of soil, but not with TFA. That's due to the extreme affinity to water, to the high mobility, and also to the persistence. What we also wanted to know, to better contextualize the findings, is compare the amounts of TFA we found with the amounts of other more prominent PFAS. There are some PFAS that are regularly analyzed because they are banned. Actually, in the European Union, you only analyze chemicals. Sometimes it seems like that when they are already banned. So this is the case for PFOA, for the big brother of TFA, and some other. And for 20 chemicals, this has to be done from 2026, because then they will be part of a drinking water limit. So we looked into this, and this was the most surprising finding, because what you see here, the purple, the small part, this is the sum of 20 PFAS that will be regulated very soon in the drinking water regulations of each member state, and another 3 PFAS that we were able to analyze, short chain PFAS. And the orange one is the short chain PFAS we did analyze and find in every sample. So what does that tell us? This shows us a complete different picture from what we are normally used to find when we're talking about PFAS. And there are maybe 2 explanations. One is that TFA is not analyzed. I think on most of the hotspot contamination sites, TFA is not analyzed, but only PFOA, PFOS, and the other well-known PFAS contaminants, and also not in just normal monitoring programs. And this is, actually also what I think is part of a political failure. So coming back to the picture of surface water contamination with TFA, the mean value, just to try to give a quantitative estimation, is comparable to 60 drops of this PFAS in an Olympic swimming pool, which is, depending on how you see it, a lot or not that much. The thing is, it's more than the European level for PFAS total in drinking water, which will be completely integrated up 2026. So that means if we, and PFAS total is meant to cover all PFAS that are potentially in drinking water. Of course, that should include TFA, but I think there are still discussions going on how to deal with that, because as you see, 80% of the water bodies that we did analyze would exceed this level. But it's not the only level. There is a lower level for the sum of 20 PFAS. We saw it before. We did analyze them. None of them did exceed this level of 100 nanogram. Also, altogether did not. But of course, this is a level quite lower than TFA. And actually, I think it's important to mention that it's a level that is not in line with the current science anymore. So it's not safe. I think we can say that. Also, authorities I talked to see it like that, because EFSA came to a risk estimation of those substances that are covered in this 20 that shows that we should have a lower legal limit for these PFAS. And interestingly, the US has agreed on a quite lower limit only a few weeks ago. It was in April when they came out with a limit of 4 nanogram per liter for PFOA, and also for a group of other very prominent PFAS limits of 4 nanogram and 10 nanogram. And what they said is that even this very small limit, which is going back to the example with swimming pools, it's 1 drop in 5 Olympic swimming pools. And even that is not safe according to the US health authorities. They say that a risk for cancer can even not be excluded if this limit is not exceeded. So 0 would be what we need. So given all that, it's very, very important, the intrinsic properties or the risk hazards that are related to this substance. I will not talk about that. I think there is also not so much studies available. My colleague will do that. Also, one question is very important. How did we get there? Because, and this is my last slide, pesticides and rain. These data come from the German authority, the environmental, also Oberumweltbundesamt, Office for Environmental, Federal Bureau of Environment. And they found in modeling with a lot of data they do have, that most probably pesticides are the main pathway for contamination of groundwater bodies and surface water bodies in Germany with this TFA. But on a global level, of course, it is the fluorinated gases, it's the F gases, because rain it comes down with rain, and rain comes down everywhere. So we find it in the oceans and everywhere. How did we get there that F gases and pesticides could lead to that bigger contamination? And with this question, I want to give over to my colleague, Salome.
Thank you, Helmut. I'm Salome. I work as a policy officer at Pan Europe, specifically on the pesticide regulation and pesticide risk assessment. So indeed, the widespread contamination that we reveal today is mostly the result of a lack of regulation of this TFA substance. And what I will try to show you today is that, in fact, this contamination could have and even should have been prevented by policymakers according to the law. So I will present to you 2 pieces of regulation that relates to water protection and that are both aiming at protecting waters and water bodies in general from pollutants such as TFA. So the first of those 2 regulations, next slide, please. Thank you, is the so-called pesticide regulation, which is governing the authorization on the markets of pesticide substances and pesticide products. So this regulation has strict authorization criteria because its primary purpose is to ensure a high level of protection, both of human health and the environment. So what it means concretely is that pesticide substances and their residues should have no harmful effect on human health and on groundwater, as well as no unacceptable effect on the environment, which require to look into the fate of those substances in surface and groundwaters. Another important element is that this regulation is underpinned by the precautionary principle. So what it means concretely for TFA and in terms of metabolite regulation, so regulation of degradation products of pesticides, it means that any metabolite which is considered as relevant, and I will come back to the definition of that, should not be found to exceed a threshold of 100 nanograms per liter in groundwater for a pesticide substance or pesticide product to be authorized. And this applies to all the uses that are assessed. Or sorry, should I present it the other way around? It should be fine that at least for one representative use that is assessed, this threshold is not exceeded. And so now maybe coming into what relevant means, it means that it's a metabolite that is considered of toxicological concerns, and to both define and identify those relevant metabolites, we have 3 criteria according to a guidance document of the European Commission. Either it's because the metabolite itself has comparable intrinsic properties as the parent substance, so the pesticide substance, or because it poses a comparable risk to organism as the parent substance, or because it has certain toxicological properties that are considered unacceptable. And now coming to TFA, next slides, please. So what happened, and we have to go back to 2003 to our knowledge, is that the European Food Safety Authority, EFSA, in charge of risk assessing pesticides and therefore their metabolites, has considered for the very first time TFA as what we call a non-relevant metabolite, which means a metabolite of no toxicological concern. And this was done in the context of a specific pesticide risk assessment, which is called Flormaton. And this was done based on insufficient investigation or insufficient information to investigate the toxicological profile of TFA. Although back then it was already known that the substance is very persistent and very mobile, which makes it a very likely, if not obvious, source of large contamination of groundwater. So this is from this moment that we knew that basically the pesticides that are forming TFA, so PFAS pesticide, could enter the market because TFA has been considered non-relevant. So this has secured the marketing of this product, and this means that no specific threshold to protect human health and the environment has been set to regulate TFA. So this is for the first regulation. The second regulation that I would like to briefly introduce to you is the EU Water Framework Directive, which is the main pieces of regulation to protect water in Europe that we have since 2000. And what it is meant to is to protect and or restore any EU water bodies. And by this, I mean lakes, rivers, as well as groundwater. And so this is underpinned by a principle of prohibition of deterioration, which means that what we want is to get a better status of our water bodies and to avoid further pollution. And this principle implies, next slide please, that a member state should take all necessary measures to prevent further pollution from relevant pollutants. And what a relevant pollutant means is defined in that regulation. And a non-exhaustive list is even provided, which includes what we call organohalogen substances. And this category of organic compounds include PFAS. So it means that based on this regulation, some monitoring and legal limits should have been applied to TFA, but this did not happen in fact. And this is why we end up in this situation today, that TFA was not regulated, was not monitored, and that we have now reached a significant level of contamination of our water bodies. So what we want to show with these few slides to you and to explain is that it's not only about environmental contamination and an environmental scandal, but it's also about political responsibility that were not taken at that time and laws that were not fully respected. And if so, maybe this level of contamination could have been prevented today. Thank you, and I will give it on to Pauline now.
Thank you, Salomé. So I'm Pauline Servant. I'm working as a toxicologist at Génération Future in France. And I will talk a little bit about toxicology and knowledge regarding TFA. So as Salomé already explained, very few studies from the public research are available on TFA. And the majority of the data that exists on TFA comes from studies conducted or funded by the industry. Under the REACH regulation, TFA producers must provide some studies, and also under the European Pesticide Regulation, PFAS pesticide manufacturer should provide some studies on TFA, which is now recognized as a metabolite for residue in food and groundwater. So as Salomé explained, this study have been requested very late, even though the PFAS active substances have been authorized for many years. So overall, the only available studies on TFA are studies that come from the industry, and mainly are studies regarding acute or subchronic toxicity. Only one long-term toxicity study was recently conducted at the request of the German UBA agency. And this study showed that the liver was the main target organ for TFA, like it is for many other PFAS. So this lack of knowledge, whether on human or environmental toxicity, is completely abnormal, given the extreme persistence of TFA and the widespread contamination of the environment by this substance. So in recent years, some new data, always from industry, are coming, increasing the concern regarding this substance. Next slide, please. Yes, in particular, a new reproductive toxicity study has been conducted and is particularly concerning. So in this study, conducted on rabbits, female rabbits were exposed daily to TFA through their food at 3 different doses. And for all the test doses, malformations were found in the babies, and these were mainly malformation of the eyes. So based on the results of this study, ECHA, so the European Chemical Agency, has identified a need to have a harmonized classification for TFA to consider it as a reproductive toxicant of category 1B. And Germany proposed at the end of last year to prepare this harmonized classification dossier, and indicated its intention to submit it to ECHA during the spring. So this dossier should come very soon on the ECHA website. So the industry has widely claimed that short chain or ultra short chain PFAS are not toxic. However, we see that this latest result demonstrates that this narrative is a huge myth. Next slide, please. Yes, moreover, we must not forget a very important aspect about TFA, that is its extreme persistence. No degradation has been observed in any study. And to my knowledge of toxicologists, it is the most persistent man-made substance that exists. So this type of ultra-persistent substance must be evaluated and managed differently from other substances. And the German UBA agency summarized it very well in a report and says that probability-based approach shows that even very rare risks become more probable the longer it takes for a substance to degrade, since the period of time during which a substance remains in the environment is greatly increased. And they also say that regulating persistent substances is not overly conservative, but reasonable according to the principle of precaution. And as we explained to you, it is clear that the principle of precaution has not been applied in Europe. So next slide, please. In order to stop these ongoing emissions and accumulation of TFA in the environment, we must act now, and we must use all possible legislative means. So first, we must ban PFAS pesticides based on their persistence and because they generate the ultra-persistent and mobile TFA as a metabolite. Also, we must adopt the Universal Restriction Project under the REACH regulation to stop the uses of F-gases that are a major source of global pollution. And then TFA must be considered as a priority substance under the Water Framework Directive. This will require member states to monitor TFA in surface and groundwater. And I will finish to say that particular attention must be paid to monitoring TFA in drinking water, because drinking water is probably the primary source of human exposure to TFA. Thank you. So we have now finished your presentation, Selina.
Thank you, Pauline. Thank you to Helmut Burtsche-Schaden from Global 2000, Salomé Ronel from Pan Europe, and Pauline Servan from Génération Futures for your input.